Hi again. So this is what the module website looks like now. And in this lecture, I want you to look behind this tab here. Two topics that I want to cover in this section. We're going to revisit the whole area of design, and we're also going to revisit routing. In this lecture, in this recording, I'm going to just focus on the design issues. So the slides are behind this tab here. So the title is Design Patterns. Not sure, you may have heard of the title before. It's not unique to web development or React development for that matter. So, and I'm kind of giving you a definition of what a design pattern is. And kind of essentially the idea is that no matter what type of software development you're doing for a particular problem domain, it's quite likely that you are trying to implement a solution to a similar problem that somebody else had previously. And so over the years, with all the software development that has gone on, there have emerged kind of generalized solutions to common reoccurring problems in the software engineering world. And so those generalized solutions to common reoccurring problems are referred to as design patterns. And so what you might find yourself doing is when you're implementing or trying to design a particular solution to a particular part of an application that you're developing, you might actually identify a design pattern that you could use to structure your solution implementation. And like anything, you build up your knowledge of these design patterns over time. Now, in general, when you are designing any type of software, two kind of qualities that you're aiming for as your end result is to have good reusability and to have good separation of concerns. These are kind of overall overarching kind of objectives. Reusability, maybe reusability within a particular project's code base, or it could be that you might develop particular classes or functions or modules that could be used in other projects. So the reusability is both internal and kind of external, if you like. Separation of concerns is this idea that each unit within your implementation, whether a unit be a function, a component, a class, each unit has only one concern associated with it. These are kind of targets that we have. Now, as well, in a very general sense, I'm sure you've heard of the dry principle, don't repeat yourself. That's something you should always aim for, and in trying to maximize the dryness, if you like, of your code, then you do finish up with reusable and better separation of concerns in your code base as a result. Now, in terms of trying to achieve all of these things, you know, greater reusability, better separation of concerns, improved dryness, in general, there are kind of two approaches. One is the inheritance approach, and the other is the composition approach. These are two approaches as to how you might break up your code base into what I'm generally referring to as units. If you will be familiar with inheritance, certainly from your coverage of Java, you remember you were kind of developing inheritance hierarchies. Inheritance is often referred to as is-a type relationships. So kind of when you're analyzing the problem domain that you're implementing some software solution for, within that domain, you're looking for is-a type relationships between various concepts or entities within the domain. And so, for example, there I'm saying an example of an inheritance type relationship is a car is an automobile. So if we imagine we had implemented this in Java, we might have automobile as a class, and one of its subclasses would be car, yeah, and it would have other subclasses. That's kind of the inheritance approach towards reusability, separation of concerns, dryness. The other approach you would be less familiar with, I'm thinking, is the composition approach. And with composition, you're looking more for has a type relationships within your problem domain. And again, the example is sticking with the same kind of domain. I'm saying a car has an engine. So if we were implementing that domain is still, let's say, sticking with Java, then you would have a car class, you would have an engine class, and a car class would have as one of its properties an object of type engine. Okay, so it's just a different way. Inheritance and composition are kind of two different ways of looking at and modeling the particular problem domain that you're developing your software solution for. That's at a very, very high level now. You can do lots of lookups on comparison between inheritance and composition, and they're kind of competing. A lot of people favor composition over inheritance and vice versa. Java is very much inheritance focused, whereas JavaScript at its core isn't. JavaScript is more angling towards the composition style of modeling your domain. Turns out that React actually favors this composition approach. So that's why that's where we're heading with this. And within the React world, then and linking this to patterns, there are a couple of design patterns that would be good to be aware of as a React developer. Now, in this lecture, I'm going to look at the first one, containers, the containers pattern. And really the reason I'm looking at it is because I use it in the lab associated with this lecture. In a later lecture, I'll cover render props. I'm not going to cover higher order components. I think once you've got a sense of composition, containers, and render props, then you might be able to actually read up on higher order components yourself as another design pattern. But the first two I'm going to cover because I actually use them in the Movies Fan app that we're rolling out. Now, before I talk about those patterns, though, I want to go off on a tangent and define what I mean by children here. So here, what you're looking at here is just some ordinary HTML. And we could describe the HTML by saying that my div element has two children, a H2 header element and a UL element. I could also say that the UL element there has three children, where the children are LI elements. So that's just defining this term children in the context of HTML, because children is actually an important aspect of JSX as well, as it turns out. Okay, back to patterns, and I want to look at the container pattern. And so I'm saying here that all React components have a special children prop. I think I might have mentioned somewhere along the lines that the props that a component receives would be the props that you actually pass to it explicitly, but there are also some other props that are passed into components by default. One of these props is a prop called the children prop. And the way it kind of works is, if you can imagine, you've got two components, component A and component B. And within component A's JSX, it's referring to component B. So we would say that component A is a consumer of component B. We've seen that already in the labs. We've got lots of examples of that. But where this children prop comes in is where A can actually pass to component B some JSX that it wants B to render. Okay, so it's kind of telling the B component, it's providing some of its UI description. The consumer is providing B with some of its UI description. And of course, the nice thing about that is that if you've got other consumers of B, then they might actually want something slightly different for B to display for it. So we've got this idea that B is reusable in different contexts, if you like. So let's just put a bit of flesh on this now and illustrate it. So I've got here a simple component that I'm calling my picture component, and you can see in its JSX, it looks like it's displaying an image, and it also has within its JSX a reference to props.children. So what this component is going to render is a div followed by an image followed by whatever this evaluates to. Okay. Here's what I would call a consumer of the picture component. And you can see here, and it's kind of a generalized one now really, you can see here how I'm actually using the picture component within the consumer. I have the ability to uh, include some JSX here between the beginning and end tag for my picture component. And so whatever JSX appears here, that JSX is going to be bound to props.children. And so the picture component will actually render this. So this consumer is kind of instructing the picture component to render whatever JSX is here, as well as the picture component rendering the image. So that's this children prop. So whenever the picture component is invoked, its props.children will also be displayed, and it will reference what is between the opening and closing tags, as I've explained. So what's the point of this? Where we're kind of decoupling the picture component from its content. As I said, the content for picture is actually, or some of the content for the picture component is being provided by the consumer of that picture component. Hence, picture is reusable by many consumers. So here's some examples. So here's a consumer where it's using picture and it wants picture, it's to include a button in part of its rendering. So this is what the picture component would render for that consumer, the image and the button. Here's another consumer, but in this case, it looks like it's passing an unordered list. So in this case, it would render the unordered list after the image. And, it's just, in this case, I'm passing it some other custom components that I've developed. And the rendering of the picture looks like this. Okay, so my picture is being reused in many different scenarios. So what we would say is that the picture is being composed kind of at runtime with other elements that are being provided by the consumer. Hence, we have composition going on here. Remember at the very beginning, I talked about composition versus inheritance. Here we have an illustration of composition happening and we're using the container pattern to illustrate composition. So when you see examples, I think it's reasonably easy to understand what's going on with this pattern. And a general point is patterns can be quite easy to understand when they're explained and you see examples of them. The difficulty or the trick is to know when to use them in your own code or to see opportunities to use them in your own code. For a very experienced developer, which none of us are, you could probably see opportunities to use patterns before you actually start writing the code. What's more common though is you've already written some code, and when you take a step back, you decide that you can refactor it to avail of a particular pattern. And as a result, your code tends to be much better structured. And also, it's easier for other people to understand, because if other people are aware of the patterns, they can see and identify the pattern within your code. So patterns actually are often described as a means of facilitating communication between developers on a team or between developers across teams. Okay, now the other patterns, the render props in particular, I'm not going to cover it here. I'm going to cover it in a later lecture. And again, the reasoning for that is I want to cover these topics as we need them in the labs. That's my kind of strategy, if you like. So we're going to park patterns for now. I actually want to talk about another thing that's kind of related to the whole area of reusability and separation of concerns. And it's something called custom hooks. This is very obviously with hook in the title. This is very specific to React. So custom hooks are hooks that you can write yourself. And the most common use case for custom hooks, although it's not the only one, is where you can actually extract some state management related logic from a component, extract that out into its own hook or into its own function. And there are two benefits to that, really. It means that our component has physically less code in it because we've actually taken its state management related code out. And also, it's quite possible that the state management code that you have removed from a component might be reusable in other components within the application or by other components in other applications down the line. Again, an example of this defining your own hooks or your custom hooks. So it looks like here we have a component related to some sort of library management system, and the book page component, more than likely from its name anyway, is a component that displays in a page about a book. And buried within that code, you can see I have a state variable declaration, and I've got a use effect hook as well. And those two kind of go together. The use effect hook and the use state hook are linked to one another in the context of this example anyway. So what we can do is we can take what I'm closing here in the box. We can take that out, physically out, and put it into its own file. And we would call that file now a custom hook. So what we finish up with is we've got a simple function which just contains the state management related code. And then our original component. Now, sorry, just before, so this is what I would refer to as a custom hook. It's kind of important to stay with the naming convention. So I've named my hook, I've prefixed the name with use, and that is again because of linting issues, because even though this is a custom hook, the same kind of rules apply to it as applies to the hooks that come with the React framework. And we've talked about those. You know, you can't bury a hook inside an if statement. It has to be at the top level within the component, all that kind of stuff. So those rules still apply. And so if you want those rules to apply to your custom hooks, then you should name your hook function, prefix it with use, so that the linters that come with the React framework will pick up any misuse of a custom hook. Okay, so that's my custom hook implementation. Now, it's really important what the hook returns. Okay, I'll come back to that in a second, but in this case, this is what I'm returning. I'm returning the book state variable reference, and I'm returning the setter method. That's really all any user of this hook would need. Here's my original component, and so now I'm just using my custom hook as if it was a React inbuilt hook. Yeah, and so there's physically less code in this component file as a result. But so the things to note is that the custom hook is an ordinary function. It is an ordinary function. That's the one on the left now. It's just an ordinary function, but obviously it can really only be meaningfully called by a React component function. has no use outside of that. I've mentioned about the prefixing the hook name, your custom hook name. And the custom hook, as I said, can return any type of collection. Typically hooks, be they custom hooks or third-party hooks or hooks that come with the React framework itself, they all tend to return a collection of some type, whether that be an array or an object. And it's really up to you to, in the case of custom hooks, it's up to you to determine what should be contained within the collection in terms of what the consumer of the hook needs to have access to from the hook. And in the case of our use book hook, all it really needs, all the component that you're using it needs is to be able to reference the book object and be able to update the book object via the setter method. And again, in the lab, you will see me using custom hooks. And that's it for this lecture. I think this is probably the shortest lecture that we will have. Okay, thanks for now.